are equal. We're not talking about the complex number today, it's just that we are doing a recap. Two complex number are equal if they are real, if their real parts are equal, and their imaginary parts are equal. Are we good? So if, as an example, we are saying A plus IB is equals to C plus or ID, this simple means that then, if that case is happening, it means A is equals to C and our B is equals to D. Did you get it? Say hello? We are still together, ne? Can we proceed? Karabo, re tswele pele. Hey, Karabo. So let's take an example. And say solve each of the following. Solve each of the following equations. For real X and Y. So figure 1, we're given 3 plus 5i plus X minus, okay, let's read that. Let's say we've got 4 plus I5 is equals to, or 5i, Z minus into 1 minus I. I will spell together. So since ourselves, we know that our Z is nothing but given by X plus IY. So a simple means that here on the what we are given, the one for X, since we know that our Z is nothing but given by X plus Y, IY, then when they say X, we know that they say what, and when they say Y, we know that they say this guy. So we first simplify this equation and make z subject to the formula. It means that we're going to have 4 plus I5 is equals to z. Then we remove the bracket. This is minus 1 plus I. Then we take everything to the side. Then you will see that we're going to have z equals to 4 plus I5. When those things go to that side is plus 1 and minus I. So our z is nothing but equals to 5 plus I4 or 4I. Therefore, which simple means that our x is equals to 5 and our y is nothing but equals to 4, while our z is this one. Are we still together?
Yes.
Okay. So now, as far as we're concerned, can we go to the next slide?
Yes.
Okay. So now, as far as we're concerned, let's say now you have, let's say solve the equation for real x and y. Let's say solve the following. Equation for real x and y. So when we're solving the equation for the real x, for x and y, let's say as an example, the first one is say 3 plus 5i plus x minus yi is equal to 6 minus 2i. How can we solve the real for x and y? How can we solve the real for x and y? So remember, I told you that that the complex number are equal if their real parts are what? Are equal and their imaginary are what? Are equal. So in this one, if you can check very nice, we can, let me change the color. We can simplify the left-hand side and the right-hand side as follows. This is 3 plus x and plus this is 5i minus yi is equals to 6 minus 2i. Are we fine? Then we can put this together, 3 plus x, and we said plus, we take out I outside, and we'll be left with 5 minus y inside. This is equals to 6 or minus 2i. So due to the reason that if we're saying a plus ib is equals to c plus id, it simply means that the real is equals to the real and the imaginary is equals to the imaginary. How good, that's why we concluded this. Are we still together? Hello? Guys, are we still together?
Yes.
Okay. So now, it simple means that the real is equals to the real. And we solve for x. It means our x is equals to what? 6 minus 3. Therefore, our x is equals to 3. And the imaginary is equals to the imaginary. Then we solve for y. This is minus y is equal to minus 2 minus 5. Therefore, minus y is equal to minus 7. Therefore, we divide by minus 1 both sides. Our y is equal to 7. Then we have solved for x and y. Is there any difficulties or any question? Hello? Is there any question? Guys, you must reply. Don't just join the meeting for chilling. Do we have any question? Andani? Raganya, do you have a question?
No, I don't.
Okay. So now, let's then say we are done with what we call the complex number. So we are going for what we call the algebra. And then after complex number, and then you guys will go for an algebra. Is that so? Hello?
Yes.
Okay. So algebraic. So when we're talking about the algebraic expression, we can talk about what we call the like terms. The like terms. But before we talk about the like terms, do you guys still remember what we say the loss of exponent? Hello? You still remember those things of loss of exponent in that one?
Yes, yes.
So like terms are numerical multiple of the same algebraic. Let's say as an example, when we're talking about the like terms, let's say we have got 2y, 3y, or minus 5y. Those are the like terms, is that so? Because they have got what? Multiples of the same algebraic quantity. What is our quantity? Is y, y, y. Are we good? So let's take as an example. Let's say we have our 5y minus 2y plus 4y. This is nothing but going to be because what you press your coefficient on the calculator and you get what? 7y. Are we good? Hello?
Yes.
Let's say you have 3c squared plus 5c squared. This is nothing but equals to 8c squared because they are the what? They are the like terms. I think this one you did, those things you did in high school. 7x plus 4y minus 3z minus let's say 4x plus 2z. then this is nothing but equals to the one for x. They are going to be grouped together. 7x minus 4x is 3x. Then 4y, I didn't write the one for y. It means, let's say it doesn't have a friend, and I didn't write anything. Then 3z minus 3z plus this is minus z. Did you get it?
Yes.
So now,
Yes.
even though I don't know why you are still doing this in your foundation, because this is like a primary case, that's all. Guys, is that so? Hello? So now, and then we know how to remove a bracket. Let's say a minus b, a, let's say c minus b. So this is the same as what? This a is going to multiply everything at the right-hand side bracket. Are we fine? And this is minus b is going to do the same. So here we have got what? Yes. So now this is the same as nothing but going to be equal to a times c is ac, a times b is minus ad, minus b times c is minus bc, minus b times that one is positive bd. Is there any question?
No.
Hello? No question, right?
Yes.
Okay. So now, and you must also know the rules that state, let's say we've got b into x minus 3 plus c into x minus 3. So if we've got two things that are inside the bracket the same, we group the coefficient on the same bracket and we take the other bracket as one. Then we're done. Are we fine?
Yes.
Hello?
Yes.
Okay. So now let's take as an example, let's say we've got ax plus ay plus bx plus by. So this is nothing but going to be equals what? On those two first, we're going to take a common factor of what? Of a. Then it means we're going to be left with x plus y. And on those last two, we're going to take a common factor of b. It means we're going to be left with x plus y. Then we apply that rule. We have something on the bracket which is the same, so we take the coefficient and we group it on the one bracket. Are we good?
Yes.
So now, let's go and do what we call the difference between two squares. Difference of two squares. So when we're talking about the difference of two squares, let's say we have as an example a squared minus b squared. So we're going to take the first one. There we go. We must have two brackets. So we take the first one and we put it on inside the square root, and we get what? We get A. Is that so? I need this one and this one cancel. And we take the second one, we put it inside the square root, this one and this one cancel, and we get what? B. It means our factors are A and B. Are A and B. Our factors are A and B. Then we've got plus or minus because it's the difference between what? Between two squares. Let's say as an example, we've got x squared minus 9. And this is nothing but equals to, we take the first one, we put it inside the bracket, the square root, they cancel, we get x, and we take the next one, we put it inside the square root, it gives us 3. Then our factors is x and 3. We've got x and 3. So because it's the difference between two squares is plus or minus, may you please do this first, x squared minus 4. May you please try to do that first. Are you done?
Yes.
So what is the factors? What are the factors? You said you are done.
We're going
Am
to
I
have
done?
x. On the first bracket, we're going to have x plus 2.
Huh?
On the second bracket, we are going to have x minus 2.
Minus 2. So can we go to the next slide? This mathematics
Yes.
of yours, you guys can make someone to sleep. Need the thickness. Anyway, let's factorize a cubic. Let's say we've got a cube minus b cube. Listen to me very carefully here. When we factorize this one, we just copy everything on the first brackets without exponent. So now we must say this one times this one, it must give us a to the power 3. So what is left? Loss of exponent. We already have a to the power 1. What is left? We're left with a to the power 2. So that when they add, they give us a to the power 3. Did you get it?
Yes.
Then we say this one, negative b, multiply this last one. We must have minus b cubed. So negative is already there. It means here we must have positive, so that when we say this one times this side times this one, it must give us this one. Are we fine? So to get b
Yes.
cubed, we are left with the b squared. So this sign over here, it must be different with this one. Since that one is minus, here we're going to put plus. And we multiply the two, a times b, ab. You get it?
Yes.
Okay, so let's do this one. Let's go to a cube plus b cube. So I told you that the rule states that we copy the first without what? exponents. Then we say this one times this one, it must give us a cube. Then we're left with a squared. We say this one times this one, it must give us positive b cubed. Then we're left with the positive b squared. We said this side must be different with this. Then since that one is plus, here we're going to have minus. Then we multiply the two, ab. We are done. Are we still together?
Yes.
Any question? No question. So now let's simplify. Let's say we have got 4x to the power of 3 minus 6x squared divided by 2x. How can we simplify this equation? We're going to take out the common factor on the numerator. What is our common factor? It's nothing but 2x to the power 2. Are we fine? So this is what the common factor does. It's a divider. Our common factor is what? It's a divider. Did you see what does the common factor do? It divides. So this is nothing but going to be equals to 2x squared into 2 goes how many times to 4? It goes 2 times. Then x squared, it goes how many times to x cubed? It cancels x squared and we're left with x minus this one is 3 because x squared and x squared, they're going to cancel each other. Then divided by 2x squared. Then this is the same as not 2x squared, but 2x. So this is nothing but equals to 2 and 2 cancel. X, it cancel 1x there. And we're left with x into 2x minus 3. Any question? Hello?
Can you please explain again?
Where?
Everything. I didn't understand. Actually, from the first step.
We said when we look at the equation, we can tell that there's
Yes.
a common factor. The common factor is something that can goes to 2, go to 4, and it goes to 6 again. So here our common factor, which can go in both 2, your 4 and 6, is nothing but our 2x squared. Are we good?
Yes.
We said it goes and divide everything if we're teaching by primary style. It goes like this. It divide everything that we said we're taking it from. You get it?
Yes.
But this equation was divided by what? By 2x. And we simplify the numerator. This is 2x squared into 4 divided by 2 is 2. And x cubed divided by x squared is x. Did you get it?
Yes.
And minus 6 divided by 2 is 3. And x and x cancel because they're the same. And we have this divided by 2x. Now this x is going to cancel this 2. And this 2 is going to cancel this one. Then it means we are left with x into 2x minus 3. Do you have any question? Hello?
No, I now understand.
Can we proceed?
Yes.
So now, as far as we're concerned, let's say now we have got this question. Let's say now we have got this question, 2x plus 4 and divided by x squared plus 5x plus 6. So on the numerator, we can tell that there's a common factor of 2. And then now you guys, you know how to remove a common factor. Or you don't know? Yeah, I must divide.
We know.
Okay. Then divided by, we can factorize the denominator. And this is x, this is x. We need the factors of 6, whereby when we multiply, they give us positive 6. But when we add them, they give us positive 5. You know those things of factorizing, doesn't it? Which is 3 and 2. So if you can check, you will see that this one and that one, they cancelling. And we're left with 2 over x plus 1. Any question? Hello?
No question.
No question. Okay, let's say now we have a divided by a plus b plus 2b divided by a plus b. And this is nothing but going to be equals to find the LCM, which is a plus b, because both of them, they can go to a plus b. We say this one, it is going to divide here, and they cancel, we're left with the 1. So that one we're left with is going to multiply with the what? With the numerator. So now it means we're going to have 1 times a, which is a, then plus a plus b, it comes and divide here, we're left with 1. 1 times 2b is 2b. Then this is your final solution. Any question? Hello?
No question.
You see that this thing is simple and straightforward.
Yes.
Factorize. To factorize is just a matter of removing a common factor. Let's say we've got a 6xy plus 15yz. So when we factorize this, we find the number that can go to 6 and 12 and 15, which is 3. And the y is on both sides. So it means we're going to be left with what? 3, it goes how many times to 6? 2 times. Y and y cancel. Then we're left with x ohm. Then plus that one, it goes how many times to that one? It goes 5 times. And the y cancel, we're left with 3. Then you're done. Are we fine?
Yes.
Yes.
Then our factors here is 5, is that so? 5 goes how many times to 15? 3. But we've got x and z plus. 5 goes how many times to 25? 5. We are done. Do you have any question?
No.
Let's say 3x squared minus 9. This is equals to 3. We take 3 outside and we'll go what? X squared minus 3. I will go to hello.
Yes.
So now we can say when you guys you know how to solve for x, is that so? If let's
Yes.
say example, if you're given 5x plus remember you were doing maths at school. This is all for x. Such a method of saying 5x equals to what? 2 minus 12. Therefore 5x equals to minus 10. Then we divide by 5. Therefore our x is nothing but equals to minus 2. Did you get it?
Yes.
Yes.
Let us proceed. Is it am I too fast?
No, you're not.
And I wish if you know that your math is boring.
It is, Shem. You're also sleeping on the other side.
I mean, like, what is the use for you guys to solve this thing instead of doing something that maybe there are others who don't even know what is going on. Solve for x and y. Is there anyone who can solve for x and y? It's a linear. Yes, you were doing maths at secondary.
Oh.
Myself, I'm interested in one thing that is not derivative and integration. Those things for teacher like complex. That's why you saw me teaching complex. Step by step. I want you to grab it because you didn't do it. It's just that you guys you don't read. It's 3 and x minus y is equal to 6. So for x and y, yeah. From our first equation, we make x subject to the formula and we get that our x is equal to 8 minus y. This is our equation 3. We sub 3 where we didn't take it. Sub 3 into 2. Then it means where there's a x, we're going to put 8 minus y. Then remember on number 2, we'll go to minus y is equal to 6. Therefore, 8 minus 2y is equal to 6. Minus 2y is equal to 6 minus 8. And let's finish to this side. Then we've got minus 2y is equal to minus 2. Then we divide by minus 2. We divide by minus 2. Therefore, our y is nothing but equals to 1. So we substitute this one to equation number 3. That's where we'll get our x. Therefore, it means our x is equals to y minus 8 minus 1. Therefore, our x is equals to 7. Is there anyone who can solve for x and y? Let's be honest. Hello? Guys, is there anyone who can solve?
No. No.
No. Can you imagine that way? We started with a complex, but within an hour we are finishing your slide. Because we can't do everything, there's nothing there. Quadratic formula. You know this one. Go and take free marks, guys. Okay? if we've got ax squared plus plus bx plus c is equals to 0. Yeah, but on complex, we must keep on reminding you, you didn't do complex. I have to. So when we saw for x when we were in grade 11, you said that by completing square, we get that x is nothing but equals to minus b plus or minus the square root of what? Of b squared minus 4ac. Guys, if you don't get total in this method, I don't know. I will show you my papers while I started there. If you don't get total while I was getting total, then you are something else. So let's say e.g., not that much only, including mainstream mathematics. You must get total. So now let's say we have got, as an example, x squared minus 2x minus 5 is equals to 0. So we're going to say x is equals to, we write the formula minus b plus or minus an is a quadratic square root of b squared minus 4ac divided by what? By 2a. Then our x is nothing but going to be equals to minus our b is nothing but negative 2, and plus or minus square root of our b is minus 2 to the power 2 minus 4. Our a is 1, our c is minus 5. Then divided by 2 into 1. Then you press your calculator, you press everything into a calculator, get x equals to, or x is equals to. So here you get what? X equals to 3,45, or x equals to negative 1.5. Is it difficult?
No.
So fine, you know. Let's end the. I will ask you the next things. Is there any question?
Auna.
Okay, bye-bye.